To do problem number 13, the question asks for negative 2 times the sine of 2x plus 3 times the cosine of 2x, and to combine that into a single expression, k times the sine of 2x plus some angle phi. And the question is to figure out what k is and what phi is to make this work. The trick here is to basically treat negative 2 and 3 as the points in a plane. So let me write this as, so negative 2, 3 is up here. So negative 2, and the distance here is 3, which makes the hypotenuse square root of 13. So let me factor out the square root of 13. So I have negative 2 times the square root over the square root of 13 times the sine of 2x plus 3 over square root of 13 times the cosine of 2x. Okay, now what I'm going to do is I want cosine of phi to be equal to this angle here. So I want cosine of phi to be equal to negative 2 over the square root of 13. And I want the sine of phi to be equal to 3 over square root of 13. Okay, so the idea is that phi will be this angle right there. So, the reason this happens, if I have sine of 2x times the cosine of phi plus cosine 2x times the sine of phi and add them up, then by the trig identity, that's equal to sine of 2x plus phi. So that allows me to work backwards, starting from this and compressing it to a single expression like this, as opposed to starting with the this here and then using the sine identity for addition to get the expansion. So this trick here allows me to take the expanded version and to compress it into a single trig function. So basically that we conclude that phi is equal to the arc cosine of negative 2 over the square root of 13. That's an angle between 0 and pi. And then it's just a matter of plugging into a calculator to figure out what phi is. So k is equal to the square root of 13, and phi is equal to the arc cosine of negative 2 over the square root of 13, whatever that is after plugging into a calculator.